Hey guys, this is Felix from lowpowerlab.com, and in this video I'd like to show you how you can go from a soda can to a high quality homemade SMT solder paste stencil. Beverage can aluminum alloy is perfect for making stencils for SMT paste application because it has the right thickness. It's also very strong and flexible and will not bend easily like other sheet metal. You may be able to do this with stainless steel sheet metal that you can buy online, but it's obviously much more expensive and you have to wait for shipping. The first step is to cut and prepare the aluminum from the can. You could do that with a cutter blade and trim the bent edges with a pair of scissors. Also, gently flatten the aluminum from its cylindrical shape. The next step is to remove the interior resin epoxy coating without sanding it. This is very important since even the finest sanding scratches will prevent a good toner transfer. I first heat up the metal with the iron for a minute because this makes it easy to remove the epoxy coating and the paint. I then use a paper towel soaked with acetone from Home Depot to rub off the epoxy and the exterior paint. This leaves shiny metal exposed, ready for a perfect toner transfer. I then prepare my board for printing the top cream layer, and I do this by first hiding all the layers except the top cream layer, which I like to give it a solid fill. I then open a cam job to create a top cream Gerber file. I make sure that there's no other layer selected. I process the job, and then I can open that file in ViewMate, which is an application for viewing Gerber files. So import Gerber, import the file that was just created. I go to Setup Decodes to select all my pads and shrink them using operations swell, and I give it a negative 7.5 mil. That works pretty well for me. I then print white on black, the whole screen content, and I use PDF Creator to print this to a PNG file. I already have the profile set up for that, and you can go to options and create your own profile to print to PNG or any other format that is convenient for you. Just make sure it saves to PNG and that you give it a high enough resolution that your printer supports. So I select my profile for PNG, I click Save. Finally, I trim the output file to only the area that I care about. I also like to horizontally flip the image, and I replace the original file with this final version, and this is ready to go to the printer now. For the toner transfer, I use cheap shelving vinyl from the dollar store. It's very thin and gives you perfect toner transfer if you follow the prepping steps so far. I stick a strip of vinyl to a blank piece of paper and print the PNG file I prepared in the previous step. Adjust your printer to maximum toner density if it has the option for that. For the next step, I wipe the metal with rubbing alcohol to remove any dust and oils. I use the top sticky note on a sticky note stack to align and hold the vinyl to the metal. I set the clothes iron to maximum heat and let it sit on top of the stack for 30 seconds or so, after which I apply pressure for another 30 seconds. When I'm done, I quickly dip the metal in cold water to cool it rapidly. The vinyl is then ready to peel off, revealing a perfect toner transfer. Now, even if the toner is transferred 100%, the toner mask might not be perfect because of your printer. So you can touch up any imperfections with a Sharpie pen. Next up, I cover the rest of the metal in clear tape, avoiding any air bubbles where the pads will etch through. For the etchant, I use a 1:3 muriatic acid to hydrogen peroxide solution. You can find the acid at Home Depot and the peroxide at your local pharmacy. The etching will only take a couple minutes, so watch for over etching, and when you see the pads coming through the other side, remove it and rinse it in cold water. The tape can then be removed and the toner wipes off with a little acetone. Overall, I think the results are very good and comparable to professional stencils. Here's another stencil I made, and this is a QFN44 package. Solder paste is very forgiving, and you don't need a perfect stencil to get perfect results. I reflow my boards in a toaster oven, following an approximation for the reflow profile of the paste I'm using, and I'm very satisfied with the outcome. So I hope this video will motivate you to try to make your own metal stencils at home using very cheap and common materials. Thanks for watching, and don't forget to subscribe and visit my blog for updates.